Oh, absolutely gaming. All right, so um, yesterday I didn't go live, but I did a lot of work on it. I mean, not like an insane amount, but I just needed to play with the light mapper and get it to a point where everything is, was better than where it was. It was super blotchy, and so I had to do some porting of my old light mapper and stuff like that. But where it is right now, I think it's pretty. I'm pretty satisfied with it. We don't have occlusion or any like shadows yet, so that's what we're going to be working on. But yeah, so what's going on here is just I made a bigger version of the debug mesh, and all I did was I the albedo color is just the normal, of course. And we just have 3 point lights and 1 directional light. And the directional light is probably coming from about over here. It's hard to really tell. But as you can see, we do have natural. Oh, it's coming from over here actually. But as you can see, we do have natural occlusion, even though there's no actual detection over here. It's just dotting, right? What's up? I can't read that, unfortunately. I only know English. I'm stupid. But down here, obviously, we don't have shadows yet, so that's what we're going to work on now. We're trying to make this mesh completely dark, of course, because this should be occluded. But also, this is the whole indirect thing, right? Like all of this light up here is indirect from the mesh below. And the reason why it's a different color is because this the albedo of this is different, right? Than this, so that's why it's multiplied, right? So all of that looks correct. It looks physically correct, and I'm happy with it. It did take an annoying amount of time to get it to this point, but that's all right. Moving onwards, also I did so before I came here, I did go onto the into Blender, and I made a texture for this. And so I was like, okay, well, let's crack open an STB image and then do all of that today as well. So I don't know if we're gonna get around to that, but that would definitely help with making things look more physically correct if it had a texture and we were sampling the albedo of the texture to do the calculations. Without that, everything does kind of naturally end up looking flat, even though I think that there is more stuff going on than we can see. But as it is right now, I have this percentage thing here just to see how long it takes, right? And so I believe that this is 3 seconds, or it's 30 seconds. No, it's 3 seconds. This is 3 seconds, so it's pretty fast. We don't have it at like insane settings right now. I think we're only at like 24 rays, so it's nothing crazy at all. And we have a tiny blur that happens afterwards to make it less harsh. Without this, I can show off what it looks like. But it is going to be a bit dotted. And I believe with higher ray counts, it goes away, that dotted quality of it, but it still is very much present. I think what really improved it was changing what we were dividing by. I was dividing by the number of hits before instead of the number of rays themselves. And so dividing by the number of rays apparently is the way to go. Because if you divide by the number of rays, you're basically doing ambient occlusion's job as well, or by the number of hits, and you're doing but as you can see, it's pretty like speckled, but with a higher number of rays and also a little bit of blurring going on, then this noisy sort of pattern kind of naturally resolves itself. I think it's also easily perceived because of the flat, natural thing we've got going on here. So with all that being said, a few things that we don't have implemented. So first of all of this was like my attempt at doing bilinear filtering for it, which honestly I tried, and then it kind of didn't really do anything different in terms of the quality, and so it's kind of a pain in the ass because this doesn't even work. The reason why this doesn't even work is because this has no this doesn't know if these texels are actually active or not, meaning if they are within the padding or not. So this really has no clue. And so if I was to make like special logic to do that, it'd kind of be a pain in the ass, because I would have to go through this texel check, and then if not, yeah, it would be a lot of logic. And I'm not entirely sure it would be worth it. For now, let's just not even worry about it. Let's just simply not worry about it. And I'll revisit it later if possible. Something else that we don't have implemented actually is rotation. I never tested if rotation actually breaks things in terms of or scale with the matrix math that I'm doing. I think theoretically it should be fine, but I have no clue. I'm going to move the mic a little bit less in my face. So I have no clue. But I wanted to test that as well. Do I have the boilerplate for it, so that I don't have to figure out how to do that again? I think I have it in here. Quad from axis angle, yeah, this. We're just gonna do one rotation on it, and then that'll be it. I don't know what I think of this is in radians, so I'm just going to do 1.2f and then see what this lands us at. While we're doing all this testing, we might as well just put it on like really low amounts of rays so that we don't have to keep waiting. Be sick. Also, we should make this a variable so that, because it's referenced more than just that. Because I also divide it out at the end, so it's kind of important for this to not be divide it out here. Okay, so I did Okay, so there is some funky stuff going on, I think. Actually, maybe not. Maybe there is. Seems for the most part to be good, but there is this like black line in the middle. Okay. Let's try it with 24 rays. Maybe it's just the ray amount. Seems close. I mean, it's going in the right direction. Perhaps not. Not though. It doesn't seem right. Yeah, we may have to. Maybe it is fine. It's kind of impossible to tell, which kind of sucks. I think like an easy way to test it is to do this, like the classic test here, where we just accumulate directly. Yeah, so the strange thing was that the classic test I've been running when I've been doing the testing on this stuff is to like do it over here and then over here, like before the self test hits. Now if I move it here, what's going to happen is that it's going to go through 100%. This is like kind of annoying to have to recompile every time and run it again, so I'm just going to run it with very little rays. Yeah. I think the direction itself needs to be transformed by the matrix. No, I think that that's probably what's happening. Let me try it. Dir equals mat formal direction. with mod 0 and dir. Let's see it. No, it's the same thing. It welcomes you with 2 unskippable ads. Well, if it makes you feel any better, that's money that you're giving me, actually. But, what's up? It's going well. I'm working on the lighting for this. And I'm just trying to make sure that we're doing a correct thing. I mean, so what's happening right now is that we've got basically these 2 models, right? And one is rotated, and so I'm transforming the lighting rays from one model to the other. But the tricky part is that they have to also traverse a BVH that's centered around the origin. So it's just a whole fucking mess, to be honest. It's just a whole fucking mess. Yeah, I do think, though, that my idea here is correct. But maybe we do need another variable for this direction, because this one should just be do I have to like do it here before I transform it? I'm still on the lighting part. Yeah, I will be for a while. It's not like something that's incredibly simple, especially when you have like multiple models and stuff that has to happen. Yeah, so what we're trying to do is we're trying to get these dark spots to go away, try to figure out what's causing them. It may actually be that this is correct, though. That's like kind of the other thing with this is like it might just be correct. The thing is that we can try doing a different angle. But at no rotation, it lights up perfectly evenly. So see, so here is like completely even. But maybe it's just maybe it's just a combination of things. Let me try we go back to this rotation. Let me try moving it to 0, and then we'll see if it aligns with the full thing, if it's gonna light up properly. Because with like multiple bounces, like God knows what actually is going on. Yeah. I do not believe it is working. I don't believe that that's correct. I think just like with position, we need another direction variable to traverse the BVH, which sucks to have like another variable here, but I think it's necessary. Because that's what this is, right? Is it transforms our position by our inverse model matrix. I think we need to do the same thing for our direction vector. And it's only used for the BVH, so let's do that. I'm just trying to figure out what I'm going to call it, which I think I'm just going to call it I'm just going to call it mod_dir. And we have to pass this into the mesh BVH as well. Is necessary, so okay. Okay. So we will do mod_dir, and then we will normalize it. Lovely rain today. Okay, and then this is what we will pass in to ray intersects ABB. You know, it's something else that I didn't really consider. That our scene BVH might not be correct. Oh, yeah, that might be something. Okay, well, let's just try to print out or debug render the scene BVH rather than the per mesh BVH. We should really just like have these here just to be, you know, testing with them. How do I do this? It's not actually this, no. No. This is just this, and we go through the globals dot scene data dot BVH nodes. So calming, yeah. I do love the rain. I'm a big fan of the rain. Used to stream out in the outside back in the day. That was a lot of fun. Redefinition of nodes. We're just going to call the scene nodes. And we're not going to worry about any of that. We're just going to render out this node. Alright, let's see if that works. All I want to see is the scene BVH on the bottom. And it's mad at me because I did not fix all of these tab mod dir inside of them, so it's mad. What did I do when I streamed outside? Code. Yeah. Back in the day, I didn't really, like, my room was being renovated, basically. So that's what I was worried about. It's just one big node. It doesn't well, I guess that inside of this node it must have both of them, so in the root, right? But yeah, I would stream on the porch. I'm gonna assume that if I move this to like -40, that it's going to split, hopefully. Or maybe I should have done more than that just to see if it splits. No, it doesn't split. Did I break that somehow when I was working on everything else, or what? Well, we may have to take a look at that BVH. Even being outside is pure passion, I guess. So that's what I was worried about. That's what I was worried about. See how the AABB isn't computed against the translated points. So that's something else we need to work on. Now I don't want to have OBBs for these things, but yeah. It's gonna be complicated. This is gonna be complicated. Holy shit. If I want to figure this out. But if the scene BVH has both of the meshes immediately in them, then it's definitely not this that's the problem. In fact, we could just cut this out just to prove my point, and the same issue will occur. So see, We can also prove that it's this. This is going to go slow, but this is me taking out the BVH out of the BVH. So we're not checking against the BVH anymore. This is going to be so slow, actually, that this is kind of... We need to be less ridiculous with this and just go to like 2 rays. So that we don't have to sit here for forever. But I have to do this before I do occlusion. Okay, so we figured out the problem now. So this projects perfectly onto here when we don't actually traverse the BBH. So that means that 100% the problem is this line of code here. So instead of... we need a mod inverse dir, I think. So let's do that. So instead of mod dir, what we're gonna do is we're gonna get the inverse of this. We're just gonna do this because this is what's used for the BVH traversal, for the ray traversal inside of the BVH. It's just the inverse because we divide. And so all I'm trying to do here is I'm trying to get that so that we can see if that's the problem. I did pass it in, didn't I? No, I didn't. Pass in mod dir here for the mesh traversal. And no, it does not appear to be correct. Now something else to keep in mind, that our PM here, we multiply the origin times this, the inverse matrix for just this. So maybe that's what I'm supposed to do. Maybe I'm thinking about this the wrong way. Maybe instead of multiplying the direction times the inverse matrix, maybe I'm supposed to be multiplying it times the regular matrix and then later take the inverse like I do for the position. So that's what I'm going to try next. We won't do that. That's basically what we do for the position. And so now we want to do the same thing here that we did there. Okay. Okay. So now we have nothing. We got nothing now. So Oh, I'm supposed to do matte for mold direction, not point, because of the W division. And there we go, we fixed it. So now, as you can see, this all lights up red. It's kind of one of those things where it's like hard to reason about, to be honest, because there's so many fucking different translations that are happening that you kind of have to just like test it until it works, sort of thing. So I'm glad that I sat here and figured that out, because you know, yeah. Something else we need to test though is scale. We don't often think about scale, but let's just try to see if this changes anything with the silhouette. We needed to do this before we do occlusion is the reason why. Well, this is just fucked in general, but like, holy shit, that's fucked. Why is it so bad? Oh my gosh. Well, I didn't really... Let's try uniform scale. I haven't actually tested scale in this engine yet. Okay, well, uniform scale works fine. Like, the collision works as well. Okay, well, I have no clue what we're gonna have to do to get non-uniform scale to work. But that's a project for another day, I think. Also, who really is gonna use non-uniform scale for collision meshes? I doubt that that's ever gonna be need to be a thing, but whatever. Okay, so that's cool. We got that figured out. Let's actually keep this like this so that we can keep testing this. Let's move our raise back to 24. Oh, right. Why was it so slow? It was because that's why it was so slow. Oh yeah, we're gonna have to figure out the BVH, huh? Yeah, so the scene BVH, the reason why it doesn't split is because it's not really truly a BVH still. I forgot to fix it. The mesh stuff is definitely a BVH, obviously you can tell, but alright. It's kind of like a KD tree, but with sorting, but yeah. Okay. So, how do we determine shadows? Good question. Glad you asked. Well, we determine shadows. So we go through our light count right now, just like our fake lights here. I want to make our directional light also a light, and then we just switch on light type here. That way we can determine occlusion for all of them at once. Would be, quite nice. That would be quite nice. How do I want to do that so that we don't have to switch case and have a bunch of fucking code in it? I think we might just have to switch case and have a bit of code in it, to be honest. I don't really want to make a function that takes in all these arguments. What do you need to take in? You need to take in light position. You need to take in the light, the position, and the normal, and that's it. And then you determine it. That's not that bad. That's not that bad. We can make one for each type of light. It's not bad. So let's make a fourth light, and that's just going to be our original directional light. We're just going to match what we have up there. These will have a straight up dir, right? We need to make that a thing, obviously. Up the lag. Yeah, the lag is, I think, Helix's autosave, which is kind of, I think it's that. There's some weird lag that happens randomly. So position doesn't matter, obviously. And then we will want to normalize it. And for now, I'm just hard coding these, but of course, later these are going to be, you know, you can play around with them or whatever. I think for this intensity, we can leave it at 0. I don't really know what R was. R was supposed to be the radius, but really that's kind of hard to solve for. So, yeah. For these lights, we're just going to each have a function. Vec3 solve point light. Okay. Alright, let's figure it out. It's going to take in the position, the normal, and we need to shoot out array and determine occlusion. We're going to shoot out array exactly like we do this, but it's going to be just in that direction from that position. The tricky part is we need to get the inverse pause still. We have to breakcast it in the same exact way that we do this. Which obviously we need a lot to do this with. So I'm just trying to figure out what actually needs to all go into this function. Because this is going to solve obviously this, so we can get scene nodes from in here. That's actually fine. We have our pause to get our inverse pause. We're gonna have the dir. So all of this is actually fine. We do need the, unfortunately, to figure out what to skip on. So I think that that's what we're gonna do. I think it's actually size t's, so I did say that I was going to do texturing in the title today, but I will. It's just a matter of there's an order of operations here that needs to get done. Okay, so a couple of things that we have to solve for first is we have to get the inverse pause. So this actually requires us to PP. We are, let's just take in the mesh pointer mesh, and then we'll get the, yeah, I really dislike this the experience of doing this right now. We're just gonna take in the local matrix for the mesh that we're solving for. We do need the normal, that is true. So slowly this is becoming like a disgusting function. we thought that it was gonna be nice and clean for like 10 seconds. Then we realized that it couldn't be. Which is completely fine. Dir, mod dir, and inverse dir. Well, first of all, we have to get the dir, which is completely fine. So we get the dir as in L. And this is normalized already. Don't need to worry about that right now. But that can be L. And then okay, so we have that as the inverse dir. And the mod dir, do we even use the mod dir? Alright, the mod dir is times the regular matrix, yeah? Yeah, it's just times the regular matrix and then you normalize it. That's all it is. And that gives us the mod dir. And now we need to initialize a new ray hit. Like so. We're gonna need to clean some of this up though, for real. And then this can just get our mesh and our try. Okay. So if not hit dot hit return 0, 0, 0. Or no. If hit. Yeah, I'm just thinking, so I have backface culling inherent in this function. And I think this is where in my old engine I made a separate function that didn't have backface culling for this purpose, but for now we won't worry about it. We need to test the I think that if the t is less than, it's either d or d squared. I think it's d, which is the distance. So if there is an object between us and the light source, really now you kind of want to make this just one function and then just solve for it differently, because now this is so verbose that it's kind of disgusting. What's the directional equation is same thing, except the distance is 1 and the light intensity is 1. Yeah, so I'm thinking that we just keep it in one equation and then we just switch internally. We just switch internally. If I'm not going to do a switch case here. There's really no point, because we're not even using the other case right now. Okay, we're just gonna put these at 1. Because we're gonna divide at the end there. Oh my gosh, I just hit the DPI button on my mouse. Oh my gosh, it's so bad. Okay, we're fine. I think that this is fine. It looks fine to me. Now we can just leave it really clean here. All right. All right, so let's give this a shot. Let's see if we have shadows, occlusion, and all that stuff. We have a seg fault. Oh no, we don't. I thought it was for a second there. It did start out really slow. Those initial raids must cost a lot, huh? Okay. I didn't get rid of the... I didn't get rid of the debug thing, obviously. But... No, I didn't. And I didn't bring back this. But this still doesn't explain anything to me because we don't have occlusion, obviously. We do not have occlusion. MN local matrix. Do I have the MN for this? I do. You gotta go to sleep. That's all right. It is quiet today, but that's completely fine with me. Have a nice night. Good luck with the lighting. Thanks. I will need it. Oh, maybe. Hold on a second. I think we're supposed to go in the opposite direction. I think that we're supposed to be going... Yeah, definitely. Definitely. Huh. Huh. Okay, well let's just try to get this working, and obviously we don't need indirect to figure out this, so let's just get rid of indirect. I think that I'm correct to to do this. I didn't send in PP. And I didn't put that there. Well, that shouldn't matter because we have backface culling, so even if we start on this surface, we shouldn't be hitting ourselves. Oh, hold on a second. This is wrong. For a directional light. Because all we care about is a hit. The distance doesn't matter if it's a directional light, obviously. Okay. Okay, well that's obviously pretty fucking raw. That's pretty fucking ugly, huh? Okay. Well, we have some shit to figure out. The lines are pretty interesting in it. Let me try something. Let me not put in mod dir at all. There we go. Okay. The tricky thing here is that I think for a point light this might not work. I'm thinking for a point light this might not work. We can test it, but I would need to figure out how to make a really bright point light to test this. I think I already had a pretty bright one, but we can try making it even brighter. That's like a pretty bright light. I guess it does work, because that would be showing through. Maybe I just don't know how direction vectors work. Or what? I thought I would have to negate it, but yeah, now that breaks it, so okay. I guess that works. Okay, so we have occlusion, we have shadow rays. And now let's bring back the indirect to see what it all looks like together. All right, that was pretty frictionless. That wasn't that bad. That was pretty frictionless. There are some, not so great spots. It's not perfect. I mean, the box blur on certain things, and the fact that it doesn't blur across triangles is also, it's not like the greatest thing ever. But I mean, the whole point of the whole indirect lighting thing is you can see this shadow here, and then over there you have like the secondary shadow, based on like how many indirect bounces are happening. So like that's the whole point of like bake lighting, is getting that right. So I'm glad that we got that at least working. But yeah, I think we're relying on blur probably a bit too much, because now with the shadows there's got to be a better way. I was looking it up actually, like a bunch of stuff about like how light mapping, what they do is they do what's called a bilateral filtering. I have no clue what that entails, but I assume that that's something that I'm supposed to do. But I try to look up like, okay, so how do I do a bilateral filter? And it was like, I don't know, you just do it. It's like, okay, well, when you put it like that, anyway. All right. Yeah, I don't know if this is gonna work for all lights, but I'm just gonna leave it right now. It seemed like it worked, so all right. Moving on. I did want to try the whole texturing thing. We don't really have the texturing thing ready. And we don't have it in our vertex layout either. So we should do that to have like UVs and then load in a texture. I've never been very happy with the systems that I've made in the past when it comes to texturing. And so I kind of want to make this one better, because that's like kind of a pain point for me. And so I made this based on just MTL format. And so I'm thinking we have a global buffer of images, yeah? And we tie this by ID to them, or what? I think that's what I did last time, and it was kind of a mess. I don't know. I don't know how other engines do it. If they have it like as a part of the asset itself, I don't think so. I think that you want it separately. But then I had what I called like a texture registry, which I like would just shove textures in while I loaded them in, and then would phase them out. And then it was basically an arena, right? Where I just had, empty free slots and things like this. But I didn't really like it because when you had to move things around, then of course you had to change everything's ID that was tied to it. So it's like, do you use pointers then? Do you use pointers? I was not going to use pointers, but I mean, it makes sense, I guess. We can try it both ways. We don't have to like commit to anything right now, but I think that's what I'm going to do. Is I'm just going to do Okay, so I was looking through the thing and I figured out what each thing is. I just googled it. And so basically I think what happens is it says at the top when you open in a .object file, it tells you where the MTL file is, and then you open that up at the same time, and then when it emits faces, then it says use MTL material, and so that you can apply that material ID to those faces. But yeah, I don't know how I'm gonna do that yet. The annoying thing, so the mesh face struct is used for multiple things, not just our triangles. It's also used for our incremental hole stuff, like a lot of our stuff. So just like putting on here like this is like not exactly the cheapest thing to do, actually, but I think that we're just gonna do that because it's just like the simplest way of doing it, and then later we can try and figure out whatever. But so each material is just going to have its own. Yeah, but then yeah, you do want a registry of things. So I can just copy my old thing. In fact, that's what I'm going to do. Flashbang. I'm pretty sure that I've just like copied this again and again, this same boilerplate every time. And it just follows me everywhere. It just follows me everywhere. Now, I don't know what like the fancy way of going about this is. I've done it like a bunch of different ways where like you take in the stuff. You get channels here, and the width and the height, obviously. But I don't understand, like, you have to take in the format beforehand when you load it in. So I don't know how to get from STB. I should look this up because I never figured this out. last parameter of STBI load is desired channels. Oh, I see. I've never actually used that. Interesting. So you can force it to RGB or force it to RGBA if you pass in 3 or 4. Oh. I didn't really ever use that. I wonder if there's like a standard way that you're supposed to do things, because I used to have just straight up yeah, I guess you could force it to RGBA and then just like load everything in as RGBA, but I feel like you just want to force it to 3. At least for now, let's just do this like in a very simple way, and then we can come back to this later. I'm just gonna put it as clamp to edge, because that will just help us debug stuff. And for now, let's just actually force it to, I don't know if it likes doing that, but let's just force it to RGB. Right, and this returns the GLUent. So do I have stuff in, oh, in a init I have load texture. Wait, what? What do I load texture in a init for? Oh, it's just here to be here. Oh, it's just there to be there. Okay. That's fine. Right, so init globals. We want to go into globals and we want to add Alright, so we're going to initialize our vectors so that we don't have to worry about anything going wrong there. I don't want to like really call it a registry. I hate calling it a registry. I don't want to call it globals either. Me and naming things, I can never. So we're just gonna get. What is type again? Am I stupid? What is type again? Oh, it's yeah. It's yeah. How did I init my stuff coming into this? I did it as 8. Alright, we're just gonna do 8. Yeah. So now we have a question here. So when we load in like an object file, we open the image file, read in the data, load it into OpenGL. But we don't actually have the buffer anymore because we free it. So the question is, do we want to keep the buffer for use during the light map sampling, or do we want to reopen it later? That's hard decision to make. That's a hard decision to make. I mean, we have the path. Like, this seems like a really easy way to create like a memory leak, dude. It seems like such an easy way to just fuck everything up. Also, we should probably just like make it the same thing, but so I was looking at this stern copy S before. Okay, so stern copy S. So size in bytes stores and a max count. What is the size in bytes? Do I really need stern copy S, or can I just use stern copy? I think we're just using stern copy today. Is this safe? Because this is the way I've always done it, and I think that it's given me trouble before, but I think it's pretty janky, not gonna lie. Consider using stern copy S instead. See, like, this is the sort of thing that keeps me up at night, not gonna lie. Inside of load texture, we could just straight up pass. For now, let's just, we're gonna force it to 3 channels anyway, so we'll just do this. Let's not even worry about it. And also, while we're here, we want to make this 128 because this, I know that we're gonna go past it. Okay. We're just gonna make something that is open texture. I'm gonna call it open image, and it takes in an image, and then all it's gonna do is this, and then it's just gonna return the Hey, what's up, Anna? I did get I'm gonna show you what I did get in terms of lighting. What we did occlusion and rotation for the models. So this is where we're at. It is sort of raw. The blur is sort of gross. The blur is gross. Okay, I know that the blur is gross, but the whole bread and butter here is this line here. So you get the interior shadow and the exterior. That's what the indirect is all about. You know what I'm talking about? The percentage. Yes, I did. You did inspire the percentage, and I did calculate the percentage. Yes, you did. I have to do material loading now so that I can do the texturing stuff. Do indirect shadow. What is indirect shadow? Isn't that already indirect shadow with the secondary shadow? Pasted every few percentages or index to speed things up since printing is so slow. Yeah, I do every 10 rows. That's what I do. I'm gonna parse my first MTL. Can you believe that I've never parsed an MTL before? Because I had my own Or maybe I did. No, I definitely did. I definitely did at some point. In fact, I should probably just like copy that code from wherever it is so that I don't have to fucking do this shit again. It's just like, this is what my worst nightmare, to be honest. .256 is also too small of a line. I'm more like a 624 type of guy myself. GLTF is king. Yeah. I'm the type of guy that I don't use libraries, and so if I want to do my own GLTF parsing again, it's gonna be cursed. I still have gltf.c, right? Like the 3000 line parser. But that shit is so buggy, and yeah, I mean it's not buggy. It's not buggy. It's just the amount of infrastructure, at least my implementation of it, because for the GLTF parsing, like I parse everything, including like animations and everything, and so I'd have to like I'd have to pour over all of my animation stuff and all of that logic and shit, and so that would be, I mean, it would probably take like a couple of days, and it's probably what I'm gonna do. But yeah, I mean the old GLTF parser works. It's just it requires everything to be GLTF, and Object is just so much more convenient for, I think, a beginning engine for sure, because there are so many bugs that can come through with like GLTF. I don't remember what it was, but it was like everything had to be exported a very certain way out of Blender, and if it wasn't, then you would have models that like their matrices would be the wrong way around and shit. That stuff is bad, especially because my engine is Z up. Everything, all of the models in the before you get to GLTF all have to be a certain way. Object is so easy because you can literally just go in the export object options and just switch it to Z up, and it just works. You know what I mean? Like GLTF, when you export stuff, like I forget exactly what it was, but it was like all of the model matrices internally had to already be set to Z up, and like it was a fucking mess. It was a fucking mess. But maybe ASIP is takes care of it for you. I don't know. But I don't like to have dependencies, you know? Time to pull your hair out for USD? What do you mean? Is it not free? Okay. So we have to create new MTL. So the first one is we do the Sternkomp line, new MTL. Oh, also every material needs to have a name. That's so true, actually. That is so true, actually. Okay. No, USD the model format. I've never heard of that before. I have to fix my transformation to up in Blender, yeah. Yeah, with object files, like for whatever reason, they always seem fine, but when exporting, but GLTF always gave me problems, especially with animations. It was always a fucking absolute mess. I don't really remember, but I'm sure I'm gonna remember when I have to do it again. at least for now, my goal is to make it so that it's agnostic, so that you can use either .object or gltf. That's the goal. I'm importing something from FBX or object. gltf doesn't read the transforms of them, right? Yeah, that's the problem with gltf, is it's the file format that does everything, but it does everything so generically that it completely fucks over every architecture that, and GLB versions of models. Otherwise I have to go through pain. Yeah, that is the gltf way. Right, so we're just going to do this, and then this will give us the name of the material. We need to make a new material as well. So we're going to have the same thing that we do for our meshes, where we have a material mat equals null. And then we'll just mat equals vector expand. It came around to kill gltf. Tesla, Nvidia, and a Disney. Wow, those are 3 of my favorite companies. Holy shit, you really know how to pick them. Now that's a fun party to be a part of, you know what I mean? Megacorp format, yeah, that sounds like exactly the type of people I want to be around, you know. USD has a few things. It's an open format though. What does open format mean? We're just gonna go down the list here. Open source, I see. Source 3D file developed by Pixar without losing GM. Source seed and stuff. gltf is just a model format. Yeah, this seems like it's used for animation, probably. Like, you know, like fucking animation, you know what I mean? I'm sure that it's good though. But to be honest, like doesn't gltf do everything though? Like why would there be another? Do you get what I'm saying? Why would there be another? Okay, I'm not gonna lie. None of this shit we care about, other than this map KD thing. Also, these are supposed to be. We're supposed to count 1, 2, 3, 4, 5, 6, 7, and then these are all gonna be 3. That one's gonna be 2. That one's gonna be 1, 2, 3, 4, 5, 6. Nice. 2, 3, 4, 5, 6, 7. 7. String compare. Let's go. Like in NVIDIA's case, they might want to use the scene over in multiple parts of the Omniverse. Like training AI. I see. The fuck is Omniverse, bro? Like the spider Omniverse? Like the Marvel Omniverse? What does that mean? That sounds crazy. That's crazy. Okay, so we need to get this. And now we have the where it is. And so after this, we want to add image to registry. Let's have this return an image pointer. So that's what we're gonna. Holy shit. My chat doesn't scroll back that far. I see. I see. Yeah, that does seem like a Disney thing, huh? That does seem like a Disney thing. Let's add image to registry with this string. The U in USD stands for universal. Unify seems it's up between most program. That's cool. That does seem useful for like Maya and you know, the people who do all that Michael Bay shit, you know. I'm sure that it's useful. Are you going to support USD at some point? It is funny that it's usually that's just literally the currency though. You know what I mean? Like that's hilarious. Come on, that's fucking hilarious. Okay. You already do? Oh, it's in a simp. I was have to Google with USD or it brings up stocks. Yeah. Alright, so we have saved the image. We've saved the image. Okay, so now how do we... So when we're loading in, we want to, first of all, when we're loading in an object file, it's going to say at the top mtl lib, owning the mtl libs 1 2 3 4 5 6 7, and then we want to load in this file, and then we'll call load mtl with that file. We do need a stir tocket first though. And then we want to load MTL with this string. And then when we're doing the faces, it's going to say what material it is. And that material has this name over here. So we need the names. We need the names. Or we could just search through our current materials. Yeah, let's just loop through all of our materials to find the material and then just like store it as an integer, because they're all gonna go, yeah, they're all gonna go, it's all going to the same place. It's all going into integers anyway. So we're just gonna do cast vec the globals dot materials. We're just gonna go through all of them and find what matches. I was gonna do it so that we have per .object file, we have those indices maybe in an array or something to be super fast, but for now, let's not even worry about it. Okay. And we will make it so that every try that we emit now also gets a material ID of current mat. I don't know what current mat ID is. What is current mat ID? Can someone explain that to me? Well, actually, you know what? Let's just have current mat ID go to 0, okay? Because we don't want to be going out of bounds. Okay, we don't want to be that serious. Okay. Okay. So that's cool. first things first, before we even get into sampling albedo in the light map generation thing, what we have to do is we want to use these text chords to actually just draw the texture from the GPU. Just, straight up, very easily. Now, that's not actually trivial because we have to update our vertex layout because I didn't make it a big one. So, yeah. So this is our light map UVs, and now we also need our this is 3. They are a different set of UVs. So that's 8. And this is 10. Now let's just stare at this and make sure that we didn't fuck anything up. Because it wouldn't be the first time if I royally fuck something up here. Okay. Alright, so let's change our main vertex thing here. It's going to have LMUV is the light map UV, obviously. When I add it to this, we want to now put this into LMUV. And what will go into regular UV is the points. Yeah, all that stuff. .uv. Okay. And the UV is definitely that. Okay. So now we also need to go into the shader and change it so that this is a LMUV. I know a lot of work that needs to get done here. Okay. And now what we'll do is we will just hard code the texture that we need to render it with. Yeah, because internally I don't have a way to actually do that yet, which is probably like me being a bit stupid. I don't know. Yeah, I mean, later what I did was I split up draw buffers themselves based on the textures and put them into texture arrays and shit like that, but I don't know what the system I'm gonna make it yet is. So I think just to get us off the ground right now, I'm just literally going to hard code the render pass. But yeah, I am gonna have to figure that out at some point. Hey Anna. So what you got tea and cookies? That sounds excellent. What system do you use for your texture binding? Because as you know, I did like the antiquated way of doing it. in my last engine, and I don't know if I'm gonna have bindless textures per se, but do you have? What I did last time was I had texture arrays, right? And then per vertex, it just indexed into the texture arrays themselves. And so I just bound texture arrays instead of textures. And that's how I did it. But I'm not sure how I'm going to do it this time. Your textures are per mesh in an array? Yeah, that's what I basically did, yeah. That's what I basically did. So, but how do you do what I never got really? So I had like global materials, right? And so I forgot how I ended up doing it, but with text type on the array to know what channel it belongs to. I see. I see. Don't have global materials outside of your scene desk SSPO. I see. Yeah, I had global materials, and so that like really complicated things. Because then you had a bunch of textures that I had like floating around that needed to be bound at different points. It's very, very complicated. But for now, I'm just gonna hard code this, I think. Do I not actually store... Oh shit. I didn't actually store... Add texture to registry. I don't actually store the eye. Oh, well that's the whole point of having it, is to have that. So I just... Okay. Okay, so and this one will be just, we'll just call it text for now. I'm not gonna stress out about it too much. Okay. The interesting thing is that we don't even need the, we don't even necessarily need it because we are already lighting it up on the CPU. But they're just super convoluted for where I'm at. Yeah, they are pretty complex. But yeah, I did have them last time, but it was like such an incredibly complex pipeline that I had to have that it was like fucking stupid. Just for meshes, you don't have them. Yeah. Yeah. I mean, yeah, I mean, in my last engine, the concept of a material was like not necessarily, you know, in the Blender way of looking at materials. So it was like, oh, material not found. Okay, well, I guess I parsed it wrong. It's something globally, I just upload its handle from the entity. I see. Then maybe that's what I should do. Maybe that's what I should do. Maybe that's what I should do. I should just make it per mesh instead of... I guess what I was worried about last time was like about like if you have a lot of, you know, stuff that uses the same material or whatever, but that's kind of rare, I'm realizing now. So let's try this. Let's see if we load it at all. Okay, so that's the problem. We don't load. Loading MTL lib. Okay, that's exactly what I want to see. So my stir talk is wrong. Probably do with what I did the render handler with the maps. Use hashes from the image data. It is rare, yeah. It's the same model usage as the issue. Oh yeah, that makes sense, yeah. But don't you just like instance your models? Like I have it where I've just like I have a struct that just is the mesh data that gets duplicated per instance. Don't you just do you have that system in place? Why does this stir talk not work? That's annoying. Unless it starts with a space, but I don't think so. Oh no, I think that what I want to do is I want to do this. But that's just super... No. Okay, well, I don't really remember how this fucking works, to be honest, so... I'm just gonna use the other way that I do this. Oh, 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 oh. Oh, oh, you're supposed to pass in null. Oh, right. Okay, that I'm just being dumb. Okay, there we go. There we go. At the moment, you're working on a local SCF scene integration. A detective that passes the same, that's it. Forgot to map and left as a for loop. Oh, you don't have instancing, I see. Yeah. Yeah, it's kind of a pain in the ass, to be honest, because you have to have, like, you have to have specific things that, that get copied per model instance, because, like, the animations need to be separate and stuff. It's like, why does it go into loading when it's a new MTL? Oh, yeah. Image. Oh, yeah. So I also have this. That's the problem, because I didn't pass in null. There, a mirror. For now, I'm just gonna. I should probably, like, have a thing where I can just turn off the indirect without having to comment out this whole thing every time. Oh my god. Failed to load image. Okay. I may have to... append onto it. I may have to append onto it this. Alright, let's see if I did that right. I may have to append onto it // for it to... Image failed to load from... Little aerial rocks. Yeah, yeah, it is. The most mistake was setting up my local SDF upload, like, if a model comprised of one mesh. Oh, I see. So did it just seg fault otherwise? Do I have a... Yeah, I do have a space. It's this new line character that I'm worried about. It's this new line character that I'm worried about. Oh no, that's that. Okay. Let's try not forcing it at all. Please. There might be a new line character at the end of it. There might be a new line character at the end of it that's causing it to break. That's what I'm guessing. If I just go to Sterlen fpath -1. Let's try that. And it worked. Okay. Okay. And we have grass rock texture. Okay, listen, it's not the most glamorous thing in the world. Holy shit, this is fucking hideous. Let's not worry about it. So you just sloppily adapt and treat them like a group of models. I'm gonna have to write multiple buffers for it. That sounds like a sticky situation. God, it's so bright. Oh, it's because we're yeah. It's because we're adding it on later instead of, I didn't actually, my dumbass didn't actually multiply. I just did add like a fucking idiot. There we go. Okay. Now we're living life. Now we're living large. The UV unwrapping also is not like, you know, the greatest thing. Also, that the reason why this one looks so warped is because its scale is ×2, so we scale it up afterwards, so that's kind of on us. Hey, this doesn't look half bad. Not half bad. Okay, so now the whole purpose of doing this is because we want to bake AO and albedo in the light map. And so what we're going to do is we're going to open the texture corresponding to the current mesh triangles. And then as we bake the light map, we're going to sample the albedo from the texture as we go along into the texels themselves. I need smooth normals. You're so right, I do. It's actually just because the model itself doesn't have smooth normals, though. Maybe we should do that. Let's do it. Yeah, I didn't put shade smooth on it. So you probably know, should I do shade auto smooth or shade smooth? Because the last time I did it, it felt like this worked better when I shade auto smooth rather than shade smooth. All right, let's try it. That's with shade auto smooth. And not shade smooth. You can obviously tell over there that it's weird. Now let's try shade smooth. Or was that shade smooth? No, I think that was shade smooth. Oh. Well then why is it not smooth on the sides? That's weird. It's because my topology isn't very dense, really? It feels weird that it's only on the bordering triangles on the edge. That it's not smooth on. Yeah. It's weird because in the middle it's perfect. Well, I mean, it is low poly, so that is... Okay, let me try shade auto smooth. Yeah, you are right. I probably should be using better models to test my shit. Oh, oh, this is fine. This is fine. This is fine. Yeah, I didn't use auto smooth. I used shade smooth. HL2 two levels. Yeah, it does give HL2 vibe for sure. I've got to make that a... Why? Okay, what's interesting here is that now our collision is messed up. It looks like. Huh. Oh, our collision is based on the probably the wrong normals now. Oh, well, this is a good thing that I tested this, because now I have to actually fix that. Okay. Okay, let's figure out how to fix that before I move on. We somewhere are probably using that normal rather than the actual surface normal, the MF. Where the fuck would that even be though? That wouldn't be in GJK. It would be in the actual triangle stuff. Oh wait, I think that this... Oh, well, this might actually be a problem then, because I think that when we load in, I don't actually... MF normal equals... Yeah, I just normalize... Yeah, that can't be the right way. Can you gen face normals off of the vertex normals? Yeah, that's what I was trying to do. This isn't the right way to do it though, right? I do vertex points to correct to the face the right way with vertex normals. I have code for it. Okay. It isn't... You don't just like add them together and then normalize it. That can't be the right way, right? Because that's exactly what I was doing here, and I think that that's the problem. I'm trying to think if there's... Let me just literally just like Google it. Average the normal vectors of all vertices belonging to that face, and then normalize. Sum the normals and then normalize it. Okay, so that I am doing it that way. Oh, you just do it the normal way too. Okay. Yeah, maybe I'll just just calculate the normals from scratch. It's just depending on the winding order, you might get backwards normals. So I think that I'm just gonna try to do the I have this function that generates a normal from scratch, but it is of course dependent on the surface norm, on the winding. So that's that's the thing. It flips it if it's backwards. Okay, that works. That works. I guess if it's coming in from Blender, then the winding order is always going to be deterministic, so it's probably fine. GLM dot. Oh, I see. Oh yeah, but oh wait, but now the lighting is. Wait, why is the lighting now fucked up? That's so weird. Because I pass in the normals directly, don't I? Hold on. Maybe I don't. I give the normal like this. Are you basing lighting off of your collision normals? I shouldn't be. Let me check. The way that I do the normals is I add the normals of the points. Oh. This was based on that. The albedo was based on the normal. But okay, there we go. Yeah, the albedo itself that I was using earlier to color the face was based on the surface, based on the collision normal. So that's why. Everything is so red. Okay. Okay, I'm glad that that's figured out at least. There are the crevasses, but I think that those are actually my lighting kind of being whack. Anyway, we're about to try and fix that. But yeah, the crevasse is kind of annoying, to be honest. I wonder if that's because of the shadow, right? We should test that. Some stuff I might like. Alright, I'll check it out. I will check it out, of course. Let me try to get rid of the... I just want to see what that little dark spot is. If it's my occlusion. It looks like it's not my occlusion. This dark spot here. I don't have indirect on right now, so it might just be It might just be that. I should probably just like turn it on just to check if it actually looks awful. Oh yeah, because it's doing a blur without it. All right. So now what I have to do is, the whole point of this was so that I can open up the textures during the light map generation and then sample from them to bake AO and stuff from scratch. Yeah, this just looks whack. This crevasse. A big reason that probably is because yeah, I'm not sure. It may also be the fact that I'm blurring. I do this blur that doesn't actually go beyond triangles, so possibly has something to do with that as well. If they're back to front, all right, yeah, thanks. I do struggle with that a little bit. Yeah, this dark spot here is really... I think that if you had a blur going across this, then it wouldn't be that bad, but yeah. It may be like you said earlier that the topology is just not... Actually, something that I'm noticing here is that... Oh my gosh. Is that this also right here has the same thing. It's the same thing. The same issue. Right here. So I don't know if this is just like literally because I'm too low poly that it can't figure out how to do it. But yeah. Oh, there you go. There. I guess it has to figure out... What are you saying? Subdivision surface and do Countmall Clark. Yeah, I feel like that's gonna just break my computer, but we can try it. With 2 levels or more. Okay. And just put it back to what it was originally. It does look kind of raw. All right, let's give it a shot. I'm down to give it a shot. That's a lot of triangles, though. Not gonna lie. We're stress testing. We should be able to handle it pretty simply, but this might be a lot of texels for the light map. For the most part, it looks fine. There are some dark spots, though, which that might be my lighting code. Overall, it looks pretty smooth though. The sharp edges were in Blender, so it's not like, that's not like on me, I think. That's interesting. I don't know why that is. Yeah, I mean the collision not working. I mean, yeah. We may have to do look off because I didn't reapply the smooth normal. Oh. Should I have applied it before or after? Because I applied it and it did nothing now. Oh, I see. I see. I see. I should have redone it. Yeah. You're so right. You're so right. Yeah, I might have to be more forgiving with the collision. I don't know what the solution is going to be, but yeah, this does just solve all the visual inconsistencies, not the collision. The blockiness is interesting, though. Those are the literal texels. Yeah, we still have this here. Some of the dark aliasing artifacts like this. So I'm not really sure. I did export it as a triangulated mesh, so it may have created some bad stuff in it. Yeah. At a larger epsilon. Yeah, it's not really that simple, to be honest, because all of these, because it's based on distance rather than just like a pure epsilon. Like just doing distance this is just gonna make it so that we're higher off of the ground, basically. Actually, surprisingly, this is better. Better. Face orientation. Yeah, as expected, it's all white. Yeah, so none of it's red. I'll have to test what the problem is with the collision. I mean, we were never like perfect with the collision. I also do feel like if we loaded it in as a GJK mesh, which I can do, and just treat it as a GJK mesh, this might take forever though, because it has to run a hole finder on the whole thing. Wow, yeah, this is a long thing. Yeah, I probably should not have done this. This is running the hole finder on the massive mesh, so. Yeah. Definitely don't want to do that with this many triangles. I think that's a bad idea, probably. Yeah. It's one of the things where you just have to kind of, I think, play around with it. Also, the fact that, like, you have to traverse the collision BVH as well on top of it. Let's actually just, like, try testing against every single triangle without doing the BVH. And see if we fall through. Maybe it's the BVH that's the problem. Multi-res modifier and displacement. I see. I see. Yeah, it looks like it's actually the BVH that's the problem. Because now we aren't falling through at all. All I did was I just made it so that we process every node. So, yeah. We take an inverse position. I want to see the way that I traverse this versus traverse this. I don't exit out here. I only exit out at the bottom of the node. So I should probably not do this. You're not falling through. Yeah, I'm not falling through when I traverse every node in the BVH. So that means that I'm this test is off somehow. What is this? Is this inverse pause? Inverse pause is TR. Yeah. Also, I'm getting issues with my BLS when you turn it off. Are you talking? Is that like a visual bug that's happening? Let's try not returning straight up. There we go. Yeah, we fell through again. It might actually be with the build of the BVH itself. We may need epsilons in the build to make things a bit, because right now everything is just super compact. I can bring back the visualization for it, but it's super like tight. Maybe the boxes just need a bit more space themselves. I think that's probably what needs to happen. This is gonna render a lot. Yeah, yeah, I think so. Yeah, because if we're using it for holy shit. Oh my gosh. Oh no. What did I do? Those are all the notes. Those are all the leaves. Shit. That's quite a bit. Yeah. 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 Holy shit. Yeah, I think we need an epsilon. Made it Holly Pyro. Yeah, it's not just that it's higher poly. I think like whatever I left it on was like good for like the low poly stuff, but I probably should not have it at that for everything because that's ridiculous. I don't know what depth I'm at. I don't even think I'm at a crazy depth though. Oh, do I not have a depth? Wait, hold on a second. Oh, wait, are we serious? I don't have a depth? No, I do have a depth. I do have a depth. Subdivide try BVH. This is the function, right? No, it's not. It's not. It's not. It's not. I didn't put depth on here? Oh. Oh. Yeah, I didn't have a depth. I didn't have a depth. I didn't set it. I think I was testing and I just didn't. Then move models and cooks. Yeah. Yeah. Okay, I fucked something up by doing this. Oh. Why does setting it to a depth break it? Hmm. And try to get away with one buffer? One buffer for what? Why does it not let me get away with... It somehow gets stuck in an infinite loop in the initializing light map texels. Hmm. No instancing. Oh, I see. I don't see why one buffer would be a problem though. God damn it. No type size for vector specified. Yeah, I feel like I probably, I don't know. God damn it. Yeah, I don't have it so that you can't have light map UVs, so I need to unify all these systems, but I don't. I'm just like not. Okay. So this is at depth something. But apparently it breaks the traversal. Any dirty is bad, but I'm trying to do early. Cutting corners. Yeah, you can come back to it. That sounds totally fine. Oh, I've got too many buffers open. I've got to deal with that. But yeah, so this is at, so just to make sure that this is doing something. Boobadoom. Yeah, so this is doing something. So this is the BVH with those. Do we have collision? We do have collision. It seems that we do have collision. So I'm guessing that in my internal walk for them in terms of lighting has an infinite loop somewhere in it. So I have to figure that out, I guess. So ray traverse scene BVH lighting. It's obviously not the scene BVH that we're worried about. It's this. Fray intersects ABB, return false. Upload to LSDF. You don't need to deal with. I'm fine. I think that this was a good idea because I typically don't stress test things until it's like way further on. So that's completely. It was a good idea, to be honest. It's a really good idea. So I personally cut a lot of corners myself. Honestly, it's holding up better than I thought it would. But there is an infinite loop here when I change the depth. When I change the depth, what I'm going to assume here is happening is so we go through an infinite loop. Which means that some like when it goes down the tree, that tree has some other part of the tree that it's not supposed to reference as a part of it. We can actually probably figure that out, actually. Recurses for forever? Yeah. I could probably test just to make sure that it does in fact recurse for forever, but it's weird because for my collision, obviously it works perfectly fine and doesn't recurse forever. So when I do it like for collision, let's see how I traverse it differently. I use the not point in AABB test. That's different. But other than that, it's actually the same. Thank God for Bineless. Yeah, that does. Bineless is the way, huh? Let's just see which one we're processing. And then let's just see if we have the same thing twice. There's also a possibility that you know, something that I'm realizing is that I don't think that this is actually wrong. Yeah, I don't think that we're actually wrong here. I don't think that there is infinite recursion. I think it's just so slow because the BVH just has to... The BVH cuts out so much time that us reducing the depth like makes it so much slower to calculate the lighting. I think that that's what's happening. Like if I lower it to like maybe like a depth like 10 or something like that, I'm sure that it'll go through fine. Maybe even not 10. Yeah, 10. Yeah, so it calculates. So it's not an infinite loop. I'm completely wrong. It's just that the lighting is so slow to calculate all the rays that it has to step through so many comparisons if you lower the BVH depth. So I don't think that we should lower the BVH depth, actually. Probably not. What we should probably do instead is make the AABBs bigger. At the end. So when we calculate AABB extents and it's a child, we should probably add on to it just slightly. So that's what I'm going to do is parent AABB dot min x, and then let's just have a like 0.005, just to, you know, and then let's just expand by that in all directions. The amount of things that I have that aren't... Hold on, calculate AABB extents. Oh no, yeah, this is fine because it takes in a pointer. Okay, so this will give us a little bit more leeway with our boxes. Should extend them off of the floor a little bit. It's so laggy. It's so laggy that it's like impossible to actually... Okay, so we still fell through. We still fell through. Just adding an epsilon to each dimension just seems like such a janky way of dealing with this, though. Also, it doesn't look like it's actually changing anything. Does calculate AABB extents? It does the... There should be such a large amount that it should visually be very clear. Well, 0.1. Maybe 0.1 is the magic number. New Yawn song? Who's Yawn? Nah, yeah, we still fall through. Even with that epsilon. Even with the epsilon. First of all, let's get rid of the debug shader that's like lagging us to the point of pain. And let's try and figure out what else we can do to... I should make a material handle struct to make my life easier with arguments. Yeah. Yeah, the whole material thing is just super painful, to be honest. It really is. It really, really is. Oh. We got rid of this. Hold on a second. We should instead be checking the actual collision point structs. If p dot collision return. The thing is, it only happens when falling, so that's also a part of it. It might actually just be a collision problem rather than a... If I put the safety up, let me see. This is the value that makes it so that we loop the collision multiple times to see. Yeah, it was causing problems earlier. So I just kept it on 1. Yeah. Maybe add an epsilon around the triangles. Yeah, I do. It's the epsilon in that case would just be the literal distance that I detect collisions with. It's basically the height of the player, right? So I already have it at 0.3, right? So technically you could like make it higher, but at that point it's like yeah. 0.5, you're never going to find a triangle that's down 0.5 because of the way the BVH works. So just adding this epsilon doesn't matter unless you literally go in to here and add that epsilon to the actual ABBs, which I would prefer not to do. I don't want to like add 0.4 because like now it's just like, are the BBH prims okay? Yeah. It's just that they're so tight around the surface that now this is going to be fine, right? Or maybe it's not fine. The problem is that, like, say you're falling towards a surface, right? You're falling, and in one frame, you're 0.5 above the surface, and in the next you're at 0, right? And you're below the triangle, right? Like, if you're below the triangle and below the surface, right? And then you already pass the BVH node that triangle that was supposed to stop you from going. Do you get what I'm saying? So you need like some sort of You need some sort of thing that's gonna stop it. Or can push. Yeah, exactly. Yeah. Yeah. And it's like, okay, well then like just resolve it, right? But it's like, how do we make sure, like, so now we've added all these extra like epsilons to the bounding boxes, right? But it's still, I don't think it still is not going to work. I may have to look at like how other engines deal with this exact problem, because it might also have to do with like very small actual epsilons inside of the comparisons as well that I haven't worked out. Like I'm doing this disk test here. Yeah, I don't know. Yeah, velocity can. Yeah, I think that it's basically it. Yeah. But even from there, it seemed to go through. So I don't really know if it's actually that. This only became a problem really when there were more triangles. So it may also have to do with the borders between triangles. It may be something that we just can't tell from I wish that I fell through when I'm just like walking around, but I don't fall through when I'm walking around. But that might be how I handle collision otherwise. I should try to like just like simplify the collision code in general so that we can test better. Yeah, so now we're just falling every time. Yeah, there we go. Yeah. We're falling on the. But I thought that I went through and I determined that this was 100% a BVH problem. Let me just test that one more time. Let me test while processing the entire thing at once. Yeah. No, yeah, it still goes through. Hold on a second, hold on a second, hold on a second. There might be like just like with the matrix multiplications that I'm going through here, there might be like weird like floating point issues. No, it's definitely not that. Am I stupid? Okay. I mean, that was probably a bug, but I didn't even know. Dude, well, that was definitely a bug. That I had this PD instead of PT there for the test. This point in triangle, do I have an epsilon here? What if I make this epsilon bigger? I think that's probably what it is. The point in triangle test is probably just like we avoid everything else. Okay, let's try just like cranking it up. You're scared of looking at solvers? It's not that crazy. The crazy stuff is like rigid body stuff. Okay. Okay, here's what I want to try next. If I just bypass the point and triangle test completely, which will obviously break everything, but no. We still fall through. Let's see the D values as we go. I have everything but the solver. The basic stuff isn't that hard. Like all this stuff is literally just triangle tests. Shouldn't it be negative infinity? No. No, because you're trying to find the lowest. I have detection of tree dynamics, test versus test. No, I mean that's just how we traverse the tree. That's not actually gonna help us. Yo, what's up, Ahmed? Oh, you're talking about the World Cup? I haven't seen it. Don't games use the prior frame's position to solve the falling through the floor due to how far you move past a triangle in a frame? Well, you do segment. You can do like segment tests, sure, with that, but I don't think that's not actually the problem right now, because right now the velocity isn't even the thing anymore. Right here, what I'm doing is I'm literally just sliding across the ground and falling through. It's on the edges of triangles, of really small triangles. That's what's happening. So in my case, it's not actually a velocity thing even. It's just that my collision logic was kind of good enough to the point where I was cheating around it before, but now I'm with more triangles, I'm falling through. So it may be something that I just have to do some more research off stream with my collision, because I don't have a full solver. I never got the full thing done, as you can see here. I had notes written out for a little bit more of it, but apparently there's like, you need like segment distance capsule tests as well. Like it's not just this. That's why I thought this point and triangle test, getting rid of it would help, but it didn't. We still aren't getting a collision. I should focus on lighting? Yeah, maybe. I mean, that's what I was supposed to be doing, but yeah. That definitely helps. Now let's try skipping the BVH and doing that at the same time. Okay, I think we've gotten somewhere. Okay, it's gross, but it's correct. It is gross, but it's correct. It's also making us go higher and higher and higher. Because the point and triangle test is so gross. Okay, but at least I know where it's coming from. It's a combination of it is a combination of both the point and triangle test and the BVH. Yeah, we're not going through the ground anymore. The bumpiness doesn't matter. Like we can fix that as long as we don't go through the ground anymore. Yeah, I probably should not be obsessing over this right now, but try and make something and then get distracted. Well, to be honest though, like this yeah, it seems like without the point and triangle test, then we just never fall through. No, you do fall through. Yeah, I probably have to. Hey, what's up, Arya? What's going on is my collision solver. So I'm stress testing with like big amounts of tries, and now I'm realizing that you could just like kind of fall through random triangles, and adding epsilon shit to the point and triangle test and the segment test doesn't really help. So I've kind of like tore apart the code base to try and figure out, see, this is the problem where we get stuck in between two triangles. I think I may just stop worrying about this for now and just like just put everything back to what it was before I got stuck on this, and then just like, because it's serviceable on its own. Basically, it's a combination of the BVH. Turns out your math was just wrong. Okay, well maybe my math is just wrong. See, it's fine until it's not. Okay, well now it's just like not doing it. Okay, there we go. See, it did it. So randomly on certain edges of certain triangles on like a very a big mesh, a big boy mesh, it just does that randomly. But this is not GJK, this mesh. So, or it's not EPA GJK. This is just literally triangle tests against the static meshes. So it's not even a whole issue. It's not a anything like that issue. Believe it or not, the GJK stuff and the EPA stuff, that stuff works fine. Have you tried testing one big triangle and test each manually to find where the issue is? No, I haven't, because the problem doesn't appear on meshes that don't have like 3,000 triangles. Like on here, you're just not gonna find the issue, because there it is. So it's like on the borders between triangles, but like here we can test this, I guess, on the smaller mesh, but it's weird because getting rid of the point and triangle test doesn't actually do anything. But yeah, I don't know. I just copied my point triangle distance and segment plane distance are just straight up just like copied. Like, so I don't really know. Maybe my math is wrong. But yeah. But this is literally just what I read, so. But I don't have segment tests. I didn't get that done. The segment distance test. I don't know if that's like necessary. But all I had was the segment plane and point triangle. But maybe I need more tests. I don't know. Oh, also, I do have this point and triangle test that happens within here, which I probably should just straight up get rid of. I think I just left that from earlier. But I don't, that's redundant code, but I also need to make that a toggle. Yeah. Does it not return a value in all control paths? It's kind of, it should just return P, I think. Because P is the point test. How do I feel the idea about using SDFs to generate a bunch of sphere colliders? I mean, that sounds like way more complicated than doing just a density field. I feel like with an SDF you can create a density field pretty easily, and that would be actually more accurate than that. This point in triangle test, I just straight up, like, this was from the old engine. Like, I don't know if this works, to be honest. Don't know what a density field is. It's what I had in the space sim. It's just literally just a 3D volume of SDF values that you just interpolate for collision. Yeah, this definitely helps. This definitely helps. Yeah, that's literally what I had for the space sim. It's just literally an SDF that you're interpolating. Yeah, it's just an SDF, yeah. But it's really good for collision because it's really fast. But obviously for the bigger mesh, that this still doesn't work. Okay, but now let's test with the BVH off, I guess. Not running it on the GPU. I want to unpack the pixels into a flat array. Yeah, what I did was I would just calculate it on both. Oh, did I fall through there? It was like, it was the same amount of like expensiveness for me to just calculate the SDF on the CPU as well as the GPU. Okay, so I'm not falling through anymore. But maybe in your case it would be different, because in my case I literally just had a density function that I could run at any point in space that just gave me the value. So for you it might be different. I think Arya just came here and then just fixed all the problems like usual. Yeah, it appears to be now that it's a BVH problem. Now it's a BVH problem. Let's try proposed, not the inverse matrix position. Not sure how much slower trilinear interpolation. Yeah, I feel like you should probably just write it out in your case. Yeah, so that's still going through. So I think like it's a two-prong issue. The first prong was my point in triangle test, just not having a big enough epsilon, and the second prong is that when we're falling, we have such a high velocity that we clip through the floor because of our BVH just being, you know, super strict on where the triangles are. So I could there's two options. I could keep on adding onto the epsilon for this, which is already fucking massive, by the way. Or I could make it so that we segment test both start and end positions during a frame rather than just the end. Is it not continuous? It is pseudo-continuous because I have a pretend little while loop here that doesn't actually go in a while loop. It used to, but then you know, the problem with turning it continuous is that this happens. So this is the problem. Is that for whatever reason you just go through. I think so. It's like an epsilon problem, right? Because I'm resolving it by the normal times the penetration distance, and for the non-GJK meshes, that puts you like right on the triangle. And so like for example, if you're like, okay, so we just want to be a little bit above it so that we don't keep hitting the collision, then you're just going to be a bumpy mess now. And so I haven't figured out the correct way to go about this. But yeah, you do just like fall through when we have more loops. I don't know. Honestly, I wasn't planning on working on this today. But yeah, this was always like something that I planned to finish. The GJK meshes work fine and they move and you can like resolve against them, but for the triangle shit, it's like I don't know. It returns the against triangles much because it's wonky is all. Yeah, but for like perfectly static meshes, here's the example I'd like to use. Let's say I want to run a hole finder on this 3000 triangle mesh. Let's just say, for example, I want to do that. And we're going to be here for like 5 minutes. You know? So like that's the deal with because hole finders are really expensive. And run GJK EPA on it. I don't know. If that's the case, then I'm doing it wrong, but like I don't know. I looked into mesh decomposition and it just seemed like super fucking complex for concave meshes. So I considered writing my own, and I tried writing my own and then failed. I kind of want to prove my point here that the GJK meshes work fine, but it's gonna literally take, like, for example, we could do the small mesh, but I mean maybe I should. Okay, I don't know why that's crashing. Why is that crashing? Oh, it's because of the light map. Yeah, I didn't really have a backup for that, huh? Yeah, if a mesh either gets imported with the per triangle BVH or the per hole BVH. So I can't really test that right now, but yeah. Maybe you are right though, and what I need to do is just like actually do like VHACD or whatever the fuck it's called that I looked up earlier. VHACD or whatever the shit. Convex holes where two shit for doing things with hanging chains together. Hmm. Yeah, I mean the convex hole stuff, like it works if it's just convex meshes, but when you have like some dude just ended up making a collision mesh out of ABBs or spheres. Yeah, I think convex holes don't do concave shapes. Yeah, yeah. Maybe then I shouldn't just do triangle tests. I don't know. The GJK stuff works good. It's just like I have no clue how to do mesh decomposition, so anyway, it's the BVH that's the problem. Or traversing the BVH that's the problem anyway. What I could do to traverse the BVH in the first place is I could just use array from start to end pause to traverse it. Like that's what I could write. Is I could just take an array and I could traverse it like I do the light map. Like I have start and proposed in here. I could literally just write through I could just do this. And then traverse it like a ray. Okay, we can try it. We can train it to an axis. Point and a radius. Testing a bunch of points. Yeah. I mean, testing a bunch of points technically is what you know, GJK and EPA are. You know, that's basically what it is. I mean, it's a bit more complicated than that, but if ray intersects ABB, we also want to test inside of this. I don't know how to do it, but we want to test if we go beyond. We want to test a segment rather than an array, which is different. It's either T exit is greater than the distance between the origin and the end. Define the center and constrain all the chains together. Yeah. Yeah, I mean, I feel like you could just like do honestly an ABB over each chain segment, or just OBBs for each chain segment, or something like that. I have to figure out how to do this because I need to make sure that this doesn't go past it. Do we really need it? Yeah, I guess we do need. Yeah, we may have to make a specific one for collision that just has an additional check in it. Um, no, T exit doesn't actually give you the. No, it just gives you the entrance and the exit of the ray, not. Okay, this is a more complicated problem than I actually thought. Yeah, I don't know. Oh, hold on a second. Can we just put in T exit is the min of the max and I think so. Now, if I know if that's correct, I have no fucking clue. But I mean, that's what I would assume. Okay. What's the problem? Oh. Okay. Okay. Okay, so now we're gonna be in a world of pain. But that's alright. Okay. Okay, I just coded that, so no clue. Yeah, no clue at all. The way I do I use the inverse position when I do the, yeah. So maybe one of these things where I have to use the inverse position, but then I need to use the inverse position for the proposed as well. And then it's like, am I translating the direction then? Probably you have to... Holy fucking shit, that's complicated. Yeah. You need to also have an inverse proposed. Or an inverse start. And then the TD. Yeah, that's a pain in the ass. That is a complete pain in the ass. Because I need to translate all these things together. Okay, so we get the TD there. And we need to transform the start as well. So SR, TR dir, and then I put TD here. Oh, but TD is the one that needs to be inversed. Okay, so then let's just... I just went to the other side. Okay. God fucking damn it. Yeah, I doubt that this is something that's going to get resolved today, though. I'm probably going to have to... I don't know. Inv S, inv proposed, and indir. I have like zero idea if that's gonna work or not. Hold on. No. Did I have yeah, let me just put it on 1. Well, that was my idea, so maybe bad idea, I guess. Maybe a bad idea. I don't understand why this wouldn't work though. This idea. We could try without this, but then it's just gonna shoot a ray through the whole thing, which you don't really want either. So either way, it's kind of a loss. Yeah, this works. Basically what this is doing is it's making the collision continuous. We're shooting a ray from start to end position, and we're ray tracing through the BVH to check everything in that direction. Problem is that there is no actual end of the ray. So it just goes on infinitely. I don't really know how to change that. I thought that this was the way. Maybe not. You're forgetting to inverse your matrix. That's a bad thing to forget to do. We could calc the dist and then try and see if it's beyond the dist, I guess. Let me look. Let me just like do a Google search. Ray intersects ABB with endpoint. Slab method. Yeah, I know the slab. I'm using the slab method. Yes, I have the slab method. Overlap boxes entirely. Calculate the exact collision point. If T-min is less than 0, the origin, the collision starts at 0. Okay, but like... where do they use end here? Okay, yeah, I have the slab method. If any intersection occurs on the forward segment, if t near is less than or equal to t far, max distance parametric length of the ray's endpoint. If t near is greater than max distance, the entire bounding mark entirely is beyond the endpoint. Okay, but how do I get the max distance? Okay. T-min is greater than T-end. Ray.T-end. Distance from origin. Okay. So apparently I can just like get the distance very simply, like testing it by really stupid run. Throw the SCF on every model. Yeah, that's typically how I go about doing things, is that I typically can't figure things out. Hopefully this is what it's asking me to do. If t enter is less than or equal to dist, I think it's that's it. T-min, no, it's T-min is greater than or equal to. Okay, let me try this. "500 years for all this debate." Yeah, I'm glad that we turned off the indirect earlier, because that would have taken forever. Okay, see, I'm falling through again. So obviously this doesn't work. This doesn't work. T-min is greater than I mean, that's the test that they have. T-end is distance from origin. Probably due to inverting a matrix. Yeah, that is. It's usually the culprit. Yeah. The start and propose shouldn't change because there is no model matrix on this thing. So transform all those on the CPU. That sounds painful. That does sound painful. Yeah, I don't know. I guess that this isn't like the... Is T end equivalent to the length between origin and end? I don't need a supercharge with personal intelligence. I'm just gonna fuck around with it to see. This should make us never collide with anything ever. Okay, so that is correct. Maybe I do need an epsilon here. Maybe that's the whole problem, is that I need an epsilon on the ray dist. Huh. Okay. Well, I solved it. Not really what I wanted to get done today, but we solved it. What the problem was that we needed to cast a ray from start to end point in a frame. And now it seems to be solved. So did you figure out if it's bad? I think it needs a bigger epsilon. Oh, I see. You haven't stopped using unsigned int on all the distances? They're not in floating point? Yeah, I think we need a larger thing. Alright, now we can go back to what we were going to figure out way back when, which is why the light map has those black spots on it. I don't know why that is, and so we've got to figure that out. I'm just going to get rid of the shadow ray. The save and read isn't, the fresh gen ones are. I see. Oh, I see. Yeah, the classic. Haven't updated the pipeline yet. Yeah. Like, what the fuck is that, huh? Let's just do light without the texture. Not using any matrix wield, way better performance. Yeah, it definitely is the light map itself. Is it just the matrix math itself that's slow? What I think I'm realizing is that it might actually be the UV unwrap. That might be the problem. It might be the UV unwrapping. That might be the problem. Let's try fucking with this a bit, I guess. Let's try lower texels per unit. Even than right now, which is like, we're gonna go to like such a low texels per unit, but I want to see. Okay, we still have it. We still have it. Huh. So let's do some testing. We check with an epsilon around that. Instead of doing this, which we never really tested against. We could try each UV pair getting a new UV. Do all of these tests. Looks like no. I'm feeling really stupid today as well. That is very true. I feel like I've been very stupid today. Let's try something. Let's try just like returning the light. Very high quality matches at this right now. Yeah, I mean that does show you if there are places you have problems, like where with me right now. So it is the normal. It is 100% the normal. That's the problem. Because if I go and do the face normal instead of the interpolated normals, no, it still is a problem. The fuck? The fuck is the problem, bro? I kind of want to turn off all of the lights other than this one, and then just test it. Let me try not adding 0.5f here. It might be... No. The fuck? It's like the normals on some very specific triangles just aren't agreeing with the lighting. I could try exporting it again, I guess. That's what I'm going to attempt to do. See if it's the model and not me. Oh, I see, yeah. I still don't know what you mean by cache when you're talking about the stuff that you do. Let's try more strict UV islands, I guess. Oh, shit. Huh. Okay. Well, that got rid of everything other than one of these. Huh. Huh. Okay. Well, my UV unwrapping wasn't incorrect. It just was too general, I suppose. Okay. Excellent. Excellent stuff. Excellent stuff, people. We can go back to not that. We can go back to this. Excellent stuff, people. Excellent, excellent stuff. Okay. Okay. Okay, okay. The Taurus looks good. So the SDF volumes to BNG. Oh, that's what you mean by cache. I see. So cache is just literally just loading it from a PNG. I see. Okay, so the painful thing now is that we have to technically go through all of the triangles beforehand and then load in all of the unique materials into an array so that we can reference them during here. It's basically going to be a buffer of buffers that we load into memory to do that. $10 FPS on some larger models, really? For doing what? What is it doing per frame? I'm sorry, I am kind of stupidly distracted right now, so that's my fault. Well, we don't even have to do it in here. We could just straight up I don't know why it's not coming up. Transforming them and traversing and ray marching. It has to be the sheer amount of meshes. 142 meshes. Yeah, that's a lot to be doing every frame. Does it have a BVH over it? Is that... Alright, we have to add this to the header. For open image, we're going to open the image. Okay, we are opening images. We just have to make sure to close them at the end. There's no acceleration structure right now for ray marching. I've become quite an acceleration structure guy. Now, I see anything that could be accelerated and I just put a BVH over it. You know? When I initialize a new thing, we do set it to null. That is the correct way to go about it. That is the correct way to go about it. Okay, so now we open all of the images. And now when we're going through, this is the math. We want the raw UVs, right? Oh wait, no, this is actually per point. It's not the goal. I see. Yeah, I get distracted. So I'm with you. I think, okay, so here's what I think. I think we have to interpolate the UVs by the barycentric business. I do have vec2 add and vec2 scale. Now that is what I'm fucking talking about, okay? Vec2 scale. We're gonna vec2 scale the UV, UVA by B0. This is what I was trying to work through today, the whole day, and I think we finally got there. There were a lot of other bullshit we had to do. Okay. We need the width and the height. Duh. We need the width and the height. Shit. I didn't really think about that. When we open it, we'll just go image width, image height. Yeah. We're just cheating it right now, but let's just in width, in height. Yes. Okay. We need to get the image. Hold on. I'm all over it. I was about to do this in here. Yes. Image with fucking Christ. Okay, there we go. Now all we need to do is we need to get the image. When we get to a new try, diff equals null. Amount diffuse. Okay, so now we have the image. So we will go image diff width, diff height. Okay. Okay. Right, yeah, you do have to do this across by the whole thing. That is true. Diff buff diff width times 3. Defoul? Defoul is crazy, bro. Defoul is crazy. Alright, let's see if this is gonna segfault. I bet it will. But that's what I'm here for. And there we go. So see, like, as long as you temper your expectations in life. Pixel 0. Oh, right. I didn't go if diff. And we still died. All right, how about this? Let's just do this the normal way. We do have the diff. Distance field AO, I see. Hold on a second. Let's try something. Let's try just sampling it at 0, and then make sure that works, and then we can figure out how to index it. Okay. So at 0 it works. So this means that somehow okay. Dibba-doom. Okay, we're close to figuring it out. Okay, so 1024. All right, let's see what the UVs are after we interpolate. Oh, some of them are negative, my friend. How the hell do we have negatives? Oh, you hate to see it. You hate to see it. Huh. Did I fuck this up? Maybe I just should clamp them. Just clamp it between 0 and 1. Does my clamp not work? Now it's turned them into balls. Your normals function? Why does my clamp not work? What are we talking about? Okay. Okay. That was what it was. It was us going into the negative. Okay, so now something that I want to try is that our lighting should now have our albedo baked into it if we did this correctly. And it does. It does. It's fucked up. It's very fucked up. Oh my gosh. Why is it fucked up? Oh my gosh, it's bad. Why is it so bad? Why is it so bad? Oh my gosh. Oh my god, it's terrible. It's fucking awful. Why does it look like that? Fuck. Okay. Okay. I guess I did it wrong. I guess I did it wrong. How about this? Let's just use UVA instead of doing the barycentric interpolation shit. Let's just do UVA. I'm going to ray trace into the AABBs. Now it's just pixelated. Now it's just very pixelated. When I hit a root node, then I'll ray march from there. That's kind of what the ray, with the ray trace inside of the BVH is doing, yeah. I think you're gonna combine them all into one mesh. That makes some sense, yeah. That does make some sense. Maybe it's not supposed to be this minus that. Maybe I wasn't supposed to negate them. No, yeah, it does just look like complete dog shit. Whoa, 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 whoa. Okay, it's definitely not that. That's for sure. Yeah, I'm stuck. I don't know. Unless this is supposed to be a 4-channel thing, which it may be. And then we went out of bounds, so I guess not. Maybe I'm not supposed to do -1. And learn LBVH if I ray trace into it. Yeah. What do you mean by cards and projection? You know what I think I'm realizing? I think I'm realizing that this is actually correct, and what isn't correct is how little texels I have. If I actually do like a normal amount of texels per unit, which is going to take forever to bake, yeah, this is with no indirect. Holy shit, this takes forever. Then we get it, yeah. Then we get it. It's just a matter of having a high enough resolution to do it. Okay, so got that working. Now to turn it back to a regular human person size. Okay, last thing I wanted to try today was doing ambient occlusion, which we probably won't be able to really see, to be like completely honest. But apparently all ambient occlusion is that you take 1 minus the hits over the ray count, and then you scale a buffer by that amount, and then you multiply times that value at the end. I don't know how I would do that every time, or if you're only supposed to do that once, or what. I don't know what the correct way of doing it is. How many rays are we doing? 24? You could simply multiply times... Yeah, let's do another buffer. Let's do another buffer just to be really clean with it. And we'll call this... I think that this is just this. Hard to explain. Generates an automatic parameterization, surface cache. I see. Which is the material. These captured positions are generated offline. Huh. Well, that's interesting. So it is like a sort of a baking thing, right? And then at the end, maybe that. So let's give that a shot. This might take forever to bake, actually. Not that bad. One piece of the tech. Lumen sounds scary. If you're scared of collision solvers, I'm scared of Lumen. What the hell did I do to this shit? What the absolute hell did I do to this to deserve this? What did I do to deserve this? This is terrible. I think that you're just supposed to do it the first time, maybe on the first bounce. You just do the first bounce. Maybe I shouldn't be doing. Also, you're obviously supposed to do T times late, obviously. Alright, let's just try it on the first one. And let's not forget to free it. That's... They trace against what's called Lumen World in caches. Caches? Interesting. I guess because it's, you know, going against regular meshes is pretty expensive, huh? So it's about like getting a representation of it that's sane. I think we're looking pretty good, you know, like all things considered. This is with only 24 rays. So there's not a lot of indirect happening here. The problem is that you get like this if the texels are too small. Then you see like this is kind of gross. Because if the texels are too small, now that we're baking albedo with it, it gets gross. But then you have the problem of like when you make it bigger, then there's, you know, good thing here is to just like put this inside of here, because we can just like parallelize everything. There's no need for everything, you know, not being parallelized. With 8 texels per unit, it's gonna look a lot better, but it takes a while. It takes a while. And yeah, this is actually with 0 blurring. But yeah, I'm pretty happy with it. It does do meshes in some bits. Proxy meshes. Oh, interesting. And proxy meshes are like, a combination of like cards, I'm assuming, and SDFs and stuff. Yeah, this is gonna take a while to bake. At 8 texels per UV unit, this does take a while to bake. Wow. Alright, I'm gonna leave soon. This was fun. Got a lot more things done today than I was planning on. The collision does work now. I mean, maybe the correct solution is to just convexify every mesh and turn it into GJK. But I've done research here and there, and like, it seems like GJK is fairly expensive for things like, giant static meshes like terrain. And so, at least based on the reading I've done, that it seems like you can get away with it at some level. DFAO, is that different than regular AO? Anyway, it's looking pretty good. It looks kind of realistic to some degree. I mean, we don't have like a lot of testing going on, but this looks pretty solid. Like if you look pretty hard, you can see the individual triangles, but that's just because of my stupid texels. Yeah. Something. Have to figure out why those. I think it may be the blur, actually. Blurring across causes these things to occur. And yeah, of course, I think with a higher resolution, obviously things are gonna look a lot better, but that's something that you're gonna have to sit here and bake for like a long time, so yeah. Yeah, I mean, like, what is distance field AO? Is it like just at places where there isn't density, then it just accumulates, or what exactly? I had a blue light here too that I'm not seeing. All right. Yeah. Yeah, I'll have to figure out what to do. All right, I'm gonna peace out. So, yeah, I'm pretty zoned out next time I think I'm going to work on getting a proper like mesh, you know, system going on where we don't have to do all this, you know, janky bullshit to debug, and you know, it's just a mess. Like getting just a simple pipeline where, you know, you initialize things and then add them to the buffer later, you know, just like getting that done would be really nice. And I guess next is going to be UI and being able to move things around and then save them. So that's what I'm going to do next. A lot of fun though, and surprisingly, you know, it looks good. So that's what matters, is that I think I got it looking good now. Honestly, looks pretty good already, and I don't have anything fancy going on. It's just pure baked lighting. So all right, thanks for hanging out. I'm sure I'm gonna work on it tonight because I'm gonna get bored. All right, peace out.